Hello. So far we have discussed about the IP addresses, routing, uh, like that. Okay. Now let us see what is a domain name system. What is domain name system? So let us see what is a domain name system. The symbol. So domain name system is a global hierarchical distributed database that provides a mechanism for mapping IP addresses into host name. So an example is given like this: www. This one is equal to this IP address. So far we were talking about this IP address. We don't know what is the domain address. Now we are coming to the domain name system. So it is a globally distributed database which contains information, a mapping with the IP address and this domain name. So why it is like that? Because remembering an IP address is very difficult. So as I told in the previous slide that the IP address means actually it is a machine. So remembering the IP address for the lakhs of machines is very difficult. So people thought of maintaining a database which contains a mapping of the IP address and this domain name. So it is like this. So why it is needed? So it is easier to remember the host names. And DNS is used by virtually all internet networking software. So any software, this DNS is required. Now, what is the first DNS in the history of computers is the ARPANET. Actually, the ARPANET is the first network in the world. That is in 1970. So in the ARPANET, people uses an IP address as in the previous case. This mapping, it is done in a text file, host.txt. It's a simple an example. And this host.txt will be contain a number of 10 numbers of machines which contains the IP address and its mapping domain. So this host.txt has to be supplied to all the machine which require this mapping. So so if there are 20 machines, we have to supply this host.txt to these 20 machines, and this host dot using that dot host.txt, he will that machine can find which machine is mapped. Okay. So if it is higher, so see the machines have became more and more large, and there is 100,000. So supplying this host.exe is became very difficult. So and it is manually updated. Say some if one for one addition is there, it has to be reflected in all the machines. All these machines we have to supply the this modification. Now let us see what could be the solution. So if this host.txt is maintained in one of the servers, and each machine, say 100 machine, refer this machine to get the IP address, and it will be fine and good. So people thought of creating a distributed database which contains host this IP address and DNS, IP address and the domain name. Okay, so that came to develop a DNS. So this is a history of a DNS server. So let us see what is an IANA. IANA means actually this DNS is this IP is very costly, and as I told, IP version 4 contains 32-bit, and nowadays it is exhausted. So giving supplying to different organization, it is almost exhausted. So we couldn't get the 32-bit address, public IP address. So who is responsible for this IP address? This organization, Internet Assigned Numbers Authority. This authority is authorized to give the IP address. So if we want a public IP address, we should give mm, a request to IANA to get the IP address because they are supplying us the IP address. Right. Now let us see what are the domains. Domain names, it is a subtree of a domain name space. It's a subtree. So this, so if we take google.com, it's a subtree. So it provides a global hierarchical addressing structure. So as in the case of our home address, what is our home address? Say, for example, in our particular area, we will have a place the state is there, and over there is district, over there is place, then house number, then our name. So that is a hierarchical structure of this global hierarchical way of addressing a particular person. So likewise, a domain is address. So it will be coming to that one. So this is a hierarchical approach. So as in our address, in the domain names space, each machine is addressed. So for example, if we take our particular VC, so we have Vice Chancellor of Kochi University, Ernakulam, Kerala. Go on. So this is a machine. It has address Reno. It is a dot. Reno dot com dot. So this is called the root of the domain name system. So just like a tree, it is put upside down. The root will be on the top. So if you take a tree and put it upside down, the root will be on the top. It's like this, and this root is defined as dot. And then, as a subdomain, first subdomain is com, and the second subdomain it is Microsoft. So this is the root domain. It's called the root. And these are called the top level domains. TLD. That is com, edu, gov, mil, in, int. These are the top level domains. Then second level domains are dot micro. Coming with after this com, this is the second level domain. This is the domain namespace structure. So as I told you, it is top level domains of com. That was specified in our picture. These are top level domains. And the domains, each so what is a domain? So each node in a tree of a DNS database, along with all the nodes below it, is called a domain. So domains can contain both host, it can contain host, it can contain subdomains. Now, okay. So let us see the DNS servers. DNS server stores information about node zones. It can contain no zones, and it can contain one zone, or it can contain multiple zones. So that is a DNS structure. DNS server can host primary zone, and also can contain secondary zone. What is the primary and secondary? What is primary? Slave. You may be hearing the words. You have heard of the word primary and slave. Master and slave, or primary and secondary. The same as this master and slave. So master zone and the slave zone. What is a master and slave? Master, the slave always came with the run with the master. So whenever master changes, the slave also will take the change. That is the same as in the primary and secondary zones. So that is a DNS server. That is a primary and secondary zones. So what fault tolerance? When a secondary service is conferring for a zone, clients can still resolve names for that zone even if the primary server further serve goes down. That is, if the primary zone is lost, it is no more getting, then the secondary zone can take over the charge as the primary zone. So it is used for a fault tolerance. Also, it can reduce the traffic. And if it is a primary server supplying is very heavy, then the secondary zones can be used. Then there is a caching only server. Caching only server which contain no zones. It's just cache the server, cache, just caching only. It's for ease of increase the speed of searching documents. Then the forwarders and the slaves. Forwarders, as I told, if you take your home machine, home modem, that modem is a forwarder. So whenever we we give a command to solve, say for example google.com, if you want to solve this IP address, we'll be supplying to this router, and router will not contain any mapping. So that will be forwarded to the next router. So maybe that router may not be containing this server, that IP address. So it will be forwarded. So these are the forwarders. Okay, let us see the zones. Coming to the next slide. Now let us see the DNS data. A master copy of DNS information for a domain zone is held by the primary names. The master copy, the main copy is held in the primary name server. And this, what is the work of the secondary name server? It will replicate the contents of the primary server to his machine. That is a job of a secondary server. Now let us see how does a DNS work. Now host query a DNS server to obtain name to address mapping. You know that if we give a www.google.com, it will search for its IP address. But if you can check whether, I don't know whether the new browser will display that status. On the status on the top bottom, you can see that if we give www.google.com, it will be resolved to an IP address, and after resolving that one, it is going with this IP address to search the particular server, that is a Google server. So host query the DNS server. First of all, what does this host do? We'll be supplying www.google.com. First job is to convert it into an IP address, and that packet will traverse through the network and get the concerned server and retrieve the information from the server. So when a DNS server receives a query, so that is a method. Now we are supplying a query to DNS server. And what is the job of DNS server? When a DNS server receives a query, if the server is a primary or secondary, whatever it is, for that domain, it will provide an authority response. That means if you are giving google.com, and it will take the first DNS server, what we have configured in our client machine. That is, we will have to give a name of this DNS server in our machine. So that name server, query will be supplied to that DNS server. So google.com may not, that DNS server may not be an authority server for this google.com. So suppose it is a Google's DNS server, and it found that it is an authority for that response. So that means authority means it will directly contain the mapping of google.com and the IP address. Immediately he will give out the IP address. So that is, so if the server is a primary or secondary, for that domain, it will provide an authority response. And if it is a cached entry from the previous server query, it will return a non-authority response. Suppose this already every information will be cached in our machine, in our browser. Browser has a cache memory, and if it is already cached, then it will give a non-authority. It is a non-authority because our machine is not authority for giving the mapping. So it will give a non-authority response. If it knows of a more authority server and does not have a cache entry, it will send the query to the more authority server. That means if in this case this is an authority response. Suppose this is an authority not authority response, it will be supplied to the next DNS machine where to find the authority server. So likewise it goes. Now let us see. As I told, we have referred to the last slide that domain system is a upside down tree. So the first it starts from dot, and these are the root domain servers. It contains a root domain server, and it is hosted in US and Europe. Okay, and it has the names a.rootservers.net. So this contains some information about the root servers. If you check the DNS, if you have configured the domain name, domain servers, you can find that this file which contains some information about the root servers. Okay. Now data files, that is our database files. So it contains one file maps domain names to IP address. One of the files contains a file which contains the domain names, so it contains a mapping, and also there is another file which contains a reverse mapping. Reverse mapping means the reverse of the IP address. This means that if we have on the left side we have a domain name, and the right side we have the IP address. So there will be a mapping between, there's a table mapping between these two IP addresses. And on the reverse side, that is in the domain names to IP address. There is another file which contains the reverse mapping. That means on the left side it contains the IP address, and on the right side it contains the domain. This is the reverse mapping. And let us see the resource record. All the records in a DNS server is called as resource record, which is simply RR. And the first resource record is the SOA record. SOA record means start of authority record. So indicates that authority for this domain. That means that SOA record means I am the authority of this domain. It says this I am the authority. So we have to specify which authority, which domain is the SOA record. Then next is the NS record. NS record means what is the name of the name server. That is the same. Because that means it's the same machine. So this shows the NS record. Sometimes if we have to specify a secondary name server, then also we have to give an NS record. It will be another machine. Then the other records will be something like this. A means address mapping to the domain to IP address. PTR means IP address to domain. This is reverse mapping. CNAME means some canonical name. MS record means the mail state. What is a mail server? And TXT means it does nothing. It's just give a simple textual information. And WKS we are not using that. And let us see a syntax for an SOA record. What is an SOA record? That means it is authority record. So the first line in a DNS file, in this database file, it is $TTL86400. You must note that this is in terms of seconds. The time. The TTL means time to live. Time to live, that is how long it should cache in a particular machine. That is given in a TTL. This time is the second. And this at means me. Or this at means it's not an email address at. In a DNS term, is known as me. That's who is me? I am Kusan.x. I am my authority. So this is a start of authority. IN means internet name. So at IN SOA Kusan.x. It's not finished. And also you must know that this dot is the actually dot is our root domain. If you take google.com, we know we don't have to supply dot in the end because explicit by default it will be taken as dot. Even if we don't supply dot, it will append dot to that. So we have to specify here quizad.ace.in dot because this means that it is the end. There are no subdomains here. This is the first level. Okay. So this shows that this is sort of authority of this domain, and this is the mail address of this domain. So you may be wondering why this postmaster dot is instead of at, but we have already defined at means me, so we cannot use at here in a mail address. So instead of giving at, we will be giving it as dot. So this is actually the name email address of this startup authority to Satellite. And it has certain parameters. Parameters mean this is a serial number, it is a fresh rate, retry rate, this one. So you'll be coming to that. What is this parameters? So startup authority's name, as I told you, this email address like any person who is responsible for this one. Then at symbols, current login as current domain. Now let's see the parameter serial. So serial means it has it can be 1, 2, 3. So we are giving a format like this. Y, this one. It's simple. So for our convenience, we are giving like this. So it must be incremented following edit to the file or secondary DNS server or other parts of DNS will not professional there. That means if something is done in our record, some domain is added, so some change is required in our database. What we have to do is we have to increment this serial number so that the other secondary servers will recognize that something has done, some modification has done in this record, in this server. To specify, it is a flag that something is done. So we have to put a flag that by increasing this serial number and says that something I have changed my domain name server resource record. So at that time, this secondary name server will be searching for this flag, and whenever it is find the flags, it will update his record because it has to synchronize. And there are some more parameters. Refresh. This is in seconds. It is 3 hours. So it tells the secondary server how often to check the accuracy of his copy of the primary data. That means this also is applied to secondary server. Refresh it. So after 3 hours, we'll be giving this primary server will be giving this machine to the secondary server also. And after 3 hours, it will again check this. The secondary server will check this primary server. This is the number which tells the secondary server to check the accuracy. Now let us see it retry. We try 2 hours. After 2 hours, if the secondary fails to pull the data, it will try again after this 2 hours. And say after say at 10 o'clock, 10 o'clock we search for updation. Then it doesn't found any updation. Then after 2 hours, that 12 o'clock again it go and retry. It's a retry time to get the information from the master primary server. Then expiry means after 1 week. After these retries, if it did not get any information from the primary server, that it will see that the primary DNS server is dead. So after 1 week again it is not getting. After retrying, it is not finding this primary server. It will consider that primary server is lost. So if secondary fails to contact a primary after this time, it will expire the data and stop giving out response to queries about this domain. So after this one, this secondary server will erase all the data of the primary server. Okay. Then the minimal time delay, that is 1 day, applied to all resource record in that file. If a server receives data from a query, it will cache from the for future view under the time. So that means all the resource record it will be cached to our local machine. So after 1 day, it will go to the new version. Suppose Google.com has one IP address. It is actually cached in our client machine. So for 1 day, it will be searching our cache. And after 1 day, it will look the DNS server whether any change has occurred. So this is that parameter to how long it should, how often it should check the primary server. So these are the parameters. Now comes the NS record, name server records. So in name server records means this is the name server. This is the name domain name server, and this is another domain name server. So in this domain name system, we have two name servers. This one and this one. There should be one NS record to point to each domain. At least there should be one record. There can be more than one record. Now comes the address and CNAME records. Address will be contained like this. Mail in A like this. So this is domain name and this is the IP. This is a mapping. Actually, this mail means is actually mail.kusan.ac.in because in the SOI record, remember that SOI record it contains kusan.ac.in or act. So we don't have to give .kusan.ac.in. So it is implied. Mail.kusan.ac.in is implied. So we have to write only simply mail. So that will be automatically updated whenever a search is coming. So mail.kusan.ac.in has an address like this, and opac.kusan.ac.in has this address. And CNAME means if mask.kusan.ac.in has the same IP address of CNAME, we don't have to give again the IP address. We can give simply CNAME. So that is CNAME. Okay. Now let us see what is an MX record. So this is an important thing. MX record means mail exchange record. It is called as mail exchange record. So if we maintain our domain in our devices, if we are maintaining a mail server, then we have to specify the mail exchange record in the DNS. That is, it specifies what is our mail server. So this is the way how to define the mail server in our domain. So this shows that mailing.kusan.ac.in has an IP address mapping before this one, and mailing.kusan.ac.in will be our MX server. That is our mail server. Sometimes we have to specify it as google.com because we may be using Google as our mail server or Gmail as our mail server. Sometimes it is smtp.gmail.com. So here, if we are maintaining our own mail server, we can specify like this. And you may be wondering what is this one, 10 and 20, right? It's the same as the secondary and primary. So this shows that it is a primary mail server, and this shows that the secondary mail server. What is the primary and secondary concept? That is, when whatever it is, when the primary goes down, the secondary will be taken. So this is the way how we have to give the primary mail server and the secondary mail server. So this is specified here. So now this is the pointer record. As I told you, on the left side it contains the IP address, and on the right side it contains the domain. So this is the pointer record. We have to specify using PTR. This is what is pointer record. Now these are some tools to see the mapping of the IP address. NS lookup, if you give NS lookup google.com, it will be supplied our IP address. Or if you want to dig means it's actually a real-time checking. So if you want to troubleshoot, we want to check the whether that IP address is existing or not, we can use this command. So dig means digging some a record in one of the mail servers. So dig, say kuzat.ac.in. If you have to give at verb, say kuzat, the DNS server of Kuzat. That is a command for dig. So now let us see how we can configure a DNS server in a Linux machine. So in the Linux machine, you maybe know that there will be a configuration file for any software. So and the configuration file will be in /etc. So for the DNS server, it is etc name.com. Actually, for a Linux machine, bind Berkeley Internet Name Domain. That bind is used as the DNS daemon. So for a DNS daemon, this named.conf is the configuration file, and this is specified. var name.conf kuzat.forward is specified in this file. In this file, we have to specify where the database is. So this name is given in this file. And let us see. In the Cochin University campus, we maintain two types of servers. That is, we contain internal primary server, internal secondary server. Of course, it's a DNS server. Then external primary server, external secondary server. So for the internal primary server, what we have to do, we have to speed up our process, because we've been doing this internal primary means only LAN people are doing it. Only we have some local IP address. So for this local IP address, we don't need to go outside and get the information. So it is specific. It is in the campus itself. So it is used for speed up our querying. So this is an internal primary server is maintained. Of course, there will be secondary server, and also to get the to supply our domain names to the external, to the public, we have to maintain a primary external server. That is, we have to specify a public IP address which contains our name server records, right? So that is a domain name server. So I would like to wind up for this domain names.